Welcome. Today I'm going to talk to you something about multicollinearity. Okay, so it has deeper impact effect in the next topic, what is called y hat versus beta hat. Okay, so here is the reference datascienceplus.com multicollinearity -in-r. Okay, it's written by Bidyut Ghosh as a R project. The important points I want to bring it up to your attention is, parameters of the model become indeterminate, standard errors of the estimates become infinitely large as the correlations among the independent variables become larger and larger. Okay, so that's the main problem, and that is going to have certain impacts. So let's quickly go over. I'm not going to go over all this theory and so on. So let's just take a look at the data set. It's about wage data set, and the model built is logarithm of the wage as a function of occupation, sector, union, education, experience. Okay, age, and what else? Sex, marital status, race, and region, I guess. Okay, race and region. Region refers to south versus north. Okay. All right. So the model fit. The model what are the results? Result of the model is this. Okay. Take a note of this. Age as a negative coefficient. Okay. Basically says that as the age increases, the log wage decreases. Pretty bad, actually, 8% per year. Okay, so that is another issue, how to interpret model when you have log variables on the left hand side and right hand side. That's an interpretation issue. But I'll tell you, every year this means simply approximately 8.5% decrease in wage. The gender is also negative. Okay, so that's fine. Male is positive, female is negative. Usually females do get less, on the average, less salary. That's what it's capturing. But we don't know whether it is a right measure or not, because the coefficients are indeterminate. That's what the main conclusion is. The R square, adjusted R square is 0.30. Okay, so keep this in perspective. Some of them are significant. That is, union and gender is significant. Marital status, race, and south region are also significant. But what happens is that these variables are highly correlated. So I'm going to go right away into this basic thing. Take a look at this one, correlation matrix here. Okay, Pearson correlation. You can see that this one is age and experience is highly correlated. That should not be surprising to you, age and experience, right? Highly correlated. And also age and education is also highly correlated. That's interesting, right? Highly correlated. Education and experience, through this age and education is highly correlated. So education and experience should also have correlation. So these are all highly correlated variables, and this is terrible, really. If you use a variable like that, the net effect what you will get is, take a look at this one. Take a look at this one. This is all you need to look at. The fact that you looked at it, that's good enough. This is what happens when you do look at what is called the VIF. Okay, the variance inflation factor. So it increases the variance, because if you remember, variance is sigma square times x prime x inverse, basically. Okay, so recall this formula later. Later on I will show you how you get that formula, but recall the one. So it's because x prime x inverse, and if the x prime x is the covariance matrix correlation, so inverse becomes, and it becomes singular, so the coefficients become huge. The inverse will become huge. That is what is happening. The VIF are highly huge numbers, and especially among the education, experience, and age, and those were the ones which are highly correlated. You saw that, right? So here, this is the correlation. Those are the ones you saw highly correlated. So my point to you is that once you correct that, there are many ways to correct. I like the summary here. You can also do the Forrer-Glauber test. That talks about partial correlation coefficient test for multicollinearity. And there are many ways to deal with multicollinearity. Okay, you can use principal component regression, ridge regression, stepwise regression, but the most important point is there are correlation variables. You can address either with either one of these, or just leave those variables out. Some other, at least you don't have to leave all the variables. You can keep one variable or two variable, but to leave the ones that are having high correlation, and you have to try remove one at a time and see what is the best model you will get. And so experience is removed from here, age, education is kept here, and now age is a different number. You remember, it's a positive number. It's 0.010. Sex is almost the same value. Okay, that's good. Education is also changed. The value of education is also changed. Not only that, these variables have become significant now, because the we have modulated down the variance covariance matrix. Okay, it was very high before. So because of the adjustment, because when we removed one variable, highly correlated variable, now the variance covariance is better estimated, and you get the better model here, which with actual important variable getting significance. Before it was not getting significance. Interestingly, the prediction is here, almost the same, pretty much the same. Here is the question. Okay, this leads to y hat versus b hat problems that people talk about it. It's not true. It is not true that y hat and b hat problems are not. People can do. If you follow y hat, don't worry about it. You go ahead and y hat. I'm going to do the b hat, or I'm going to do b hat. I'm going to do y hat. You go do whatever you want regarding b hat. It doesn't matter. It looks like there is a tendency to separate out this problem. They are not, because here you can see the interpretation is going to be very, very harsh, very difficult, very incorrect. So the adjusted R square is, the predictability is same. That's where I'm coming. Y hat is about predictability, and b hat is for interpretation, policy changes, and overall strategy, rules development, and so on. So it is not true that they are different. You have to address together well. So basically it means you have to build the right model, whether you apply for prediction or beta hat problems. Okay, thank you very much everybody. That's the education for today. Enjoy your learning. Bye.